Hello, my name is Osama Maklad. I am a lecturer in mechanical engineering here at the University of Greenwich. I teach my students mechanical engineering topic like heat transfer, thermodynamics. I will explain today the new equipment that the university have invested in to increase and enhance the student experience and improve their practical insight. This new experimental setup is a two-stage compressor. Many industrial processes and applications require pressurized air and compressed air. So in here we have a two-stage compressor. In the first stage, the air is compressed to a certain pressure, and then in the second stage goes to a higher pressure. And once the pressure setting reach to the value required, the compressor shut down, and when the air is consumed, it returns to back on. This explains to the students how the SCADA system works and how to monitor the temperature and the pressure at each point of the system. So it's a simple model for a bigger setting in industry, for example. The students like to be involved in a practical situation, so when they go to industry or a bigger power plant, for example, they are more confident and they have seen something similar before. On here, in this experimental setup, it prepared the students to understand the fundamentals of heat transfer. We experience in our daily life heat transfer with our boilers, with our heating. So in this experiment, we are studying the heat transfer by free and forced convection. This air duct push air through 4 different experimental geometries. We have a heat transfer over a flat plate, or over a cylinder, or over a cylinder bundle. These different geometries, by measuring the heat transfer coefficient, is really important design parameter. So when you are designing heat exchanger or for example flow around heating element, so measuring these parameters is very important in the design process. The data logger collect all the measurements, the heat transfer, amount of heat flux, and draw a relationship between the parameters that's needed. Have you ever wondered how electricity is generated? So in this setup, that's a small steam power plant to generate electricity, but it's a small engine, a piston engine operated by steam. So we have a water tank and a boiler. This boiler boils the water so we can generate steam at high pressure and temperature that can generate electricity in a very small simple model, but it's the exact same idea that explains the electricity generation by steam power. By increasing the load after the generator, you need to burn more fuel and more power. And we will see next the gas power plant. On this gas turbine model, the other type of electric power generation using gas turbine. This setup is the main idea of gas power plants and airplane engines as well. The main idea that you have a compressor connected to a turbine, and the compressor get the air and increase the pressure to enter the combustion chamber, so we can increase the energy of the air, and these high energy gases enter the turbine. So this turbine is connected to a generator, can produce electricity, or the same setup we can change to a nozzle, and this nozzle provide a thrust for the airplane to move forward. In the new modern power plants, they always combine the steam power plant and the gas power plant to increase the efficiency. And we monitor the temperatures and pressure at every point in the system. And is a really good example for industrial practice, and the students found it very beneficial for them to know before they graduate.